coming to Salt Lake City. I guess not because of me, but having said that, I'm still very happy that you came. So we are going to talk about threat detection strategies around Kubernetes. This is a 30-minute talk. This is obviously not enough to discuss this topic. Therefore, we are going to be like very up here, and somewhere in the middle I will jump down and go up, and like we'll try, but I will try to make sense here about everything. And my point is really to talk a little bit about the open source projects around Kubernetes and threat detection, their different threat detection strategies through different examples. So just a few things about myself. I'm Ben, one of the maintainers of the CNCF project Kubescape. This is my 4th talk in Cloud Native Rejects, which means that I get rejected a lot by KubeCon. But having said, I'm in the program community of KubeCon, therefore, obviously I cannot accept it too much there. So we had a world, even the security world, we had like a few years when everything was about agentless and posture. And today we start to see a new wave of getting back the focus to the runtime and runtime detection and response and protection world, which is, I think it's very healthy. And it's really something that, since this is the place I'm coming from in my career, it's something that's really good for me as well personally, because it's my home court. So we're going to talk about, I will give a few slides here about a little bit defining the problem space. Then I will take 3 open source projects, all of them CNCF projects that are trying to answer these problems. I will bring you 3 attack scenarios and how these different projects are behaving under these attack scenarios, what's their value they are giving. And then at the end we'll discuss, we'll try to evaluate together, what's the bottom line here. And again, I'm one of the maintainers of one of those projects, so I will try to be very neutral, but you were warned that I might be not completely objective here. So as I told you, for a long time, for the last few years, we were very focused on application posture, security posture, vulnerability management, configuration scanning, trying to say when and how an attacker can get into your environment, which is, by the way, it's a great thing. It's an important thing. It's a super hard thing to do it right. It's a lot of investment from the security teams, and not just for the security teams, but for DevOps and dev teams, because it's giving a lot of work. But on the other hand, the number of 0 days and number of attacks are going up in cloud environments by all reports. And everyone who is in the security space knows that this is a very complex arena because we don't have open source information for a lot of time. So we don't really know how much attacks are happening because organizations are not really ready to share this information. But there are tons of examples where things were published, and is really seeing a rise in real attacks in real time. Despite that, we have a tons of tools that should be assisting us in preventing those attacks. So when today, in this example, there are a lot of, I would say, let's put it like this, there are a lot of commercial solutions that are coming here and giving you runtime protection solutions that are covering a lot of the solution space we are working in. So both endpoints, server nodes, cloud logs, everything together. A lot of them are claiming that they are doing it. There is another question how effective they are, but we are today focusing on not on all the space, but only somewhere around, the Kubernetes, the container workload, and the application phases. This is the place where all these projects are focused on, and therefore this is the. I'm not claiming to talk about all the other layers. So as I told you, we are going to talk today about 3 CNCF projects. First of is Falco. Is here anyone who haven't heard about Falco? No. Oh, you haven't heard. Okay. So Falco is a graduated CNCF project. I think it was graduated in last KubeCon. It's one of the CNCF projects who existed well before Kubernetes was even around. Falco is a rule engine for runtime detection, obviously focused on security. The general idea in Falco is that its rule engine and its language enables you to define different rules and rule sets for different sources of information. The main thing we are going to talk about is system calls events in a Kubernetes node, but Falco is wider and can be connected to very, very different data streams. It's been out for a lot of time, and it's a very, very well-tested project. The second is Tetragon. Tetragon is, I don't know how to exactly define it. It's a sub-project under Cilium, and it's been around for not very long time, but as you know, everyone who knows the Cilium team is a great team with a lot of great professionals around it, and it's I would say it's always a force to reckon with because these are really good guys. But the Tetragon is really focused only on the eBPF side of the detection, and it's a very Kubernetes native project with all the capabilities of syncing data to different outputs and defining rule sets on Kubernetes CRDs. Sorry. Went ahead of. So Player 3 is a project where I'm a maintainer. Kubescape. Kubescape started beforehand about the postures and configuration scanning, vulnerability scanning, and so on. And we had a shift in the project in the past year and a half, where we got a lot of requests from trying to detect runtime attacks, and we connected with, we decided not to implement eBPF on ourselves like the 2 other projects did, but joined forces with the Inspector Gadget team to connect different events in the eBPF and do a very different approach to runtime detection, which is detecting events not just based on rules, like if I see a process that is started from a temp directory and it looks strange, then I need to alert because attacker could do that. But this project is focusing very much on anomaly detection, so trying to define how an application is working, and after a predefined learning period, starting to alert on any deviation on the behavior from that base behavior. So the biggest, the approach here with all 3 is a little bit different. Falco is coming again because they were the first and they are here for 10 plus years. They have a bunch of rules. There is a lot of, I would say, tribal knowledge around Falco, documentation, everything that enables to define rules and detection rules around the eBPF stream of Falco. Tetragon is the big difference from Falco is that instead of streaming all the eBPF events of what's happening on a node into a user space application and running a rule engine about that, Tetragon, what it tries to do is evaluating all these events inside the kernel in eBPF, which has a huge advantage on the performance perspective, but it makes the detection rules somewhat limited because they are constrained with all the eBPF constraints around that. And as I told you, Kubescape is more into baselining application behavior and alerting on deviations from baselines. So, as I told you, we are going through 3 attack scenarios and see how these tools are behaving. So the first attack scenario is a command injection. When in this case, an attacker is attacking an application running inside the Kubernetes cluster, and the attacker has identified that there is a command injection attack and is able to send a payload, an HTTP request with a payload to that application, which then spawns a process, a cat /bin cat process, which dumps the service account token of that pod to the std out, and the std out gets back to the attacker through the request, which would be like it's a very simple attack. And just for you to show, why is it not auto starting? So it's a very I've created a demo application for that. So there is this ping tool application, which is the vulnerable application. I can ping any address. Now, as you can see in the next try, I'm not just trying to ping this IP, but also trying to inject a command. Let me stop. Just for everyone who's not understanding that what's happening here, this string is taken by the application and just invoking a shell. And since the semicolon is there, it interprets the ls as an extra command. And therefore, the attacker is able to inject the ls command here. So as you can see here up in the response, you see that there was the index HTML and ping PHP is the output of the ls. And now on, I will do as an attacker the real attack here. And I will try to steal the service account token of the pod, which is, again, this attack is, I'm not saying that every application is vulnerable to this attack, but from application security perspective, these are the kind of attack we are very concerned that will happen on a real, in a real environment. And surprise, surprise, we have the service account token in the response. So, oh, sorry. Whoa, how do I switch to the next slide? Sorry. Okay, I'm stuck here. So, how these 3 different rules are behaving, and again, guys, I'm sorry, there might be maintainers here of both projects, and maybe they will say, oh, this is not working like this and working that way. It's sure, I'm trying to summarize here the experience. So what happens with Falco with default rule set in this attack was very surprising for me because nothing, it alerted on 0 things. I really expected it to find out that the binsh that was executing here is responding to sending back the data through the network socket, but it didn't. I found a way to enable, to configure this specific thing and to have it alert, but it wasn't very easy. So I needed extra configuration for that. Also, there is a rule in Falco, which is not enabled by default, but you can enable it, and it will alert if the pod is accessing the service account token file. Now, remember this because we'll return to this. There is a problem here. I have to tell you that for Tetragon, I needed to do a lot of massage the service account token was actually rather easy because there was I could create a policy where with Tetragon which notified that someone is accessing the service account token. But again, to show you that there was a CAT process that was spawned by another process that has a network connection, and the STD out is going there was not possible for me, at least for my limited knowledge. It might be done, but again, take these responses as someone that if I'm failing with my in general knowledge about this area, so a security engineer will also have hard problem defining this. So with Kubescape, what we found out that after the learning period finished, it raised alerts on unexpected processes that were launched and unexpected file access that it detected. So it detected that there was a file that was accessed that wasn't accessed before, and there was a process that started that he didn't saw before. Now I'm bringing you another attack. In this attack, the attacker is not trying to extract the credentials, but uses a server-side request forgery attack on an application, which then creates a request for an AWS API. So the attacker is able to send a payload that causes the application to send a request to AWS. And since this application has credentials to the AWS API, that request will be answered with an OK with the AWS API. In this case, I saw that it's in this request, we are creating a new user in IAM and so on. But I guess you get the gist of the idea. So what work? So I could configure a Falco to alert on access to the AWS metadata service. Again, this is not a rule that is defaultly on in Falco, but there is a rule. The same guy went to Tetragon. I could define, there is an example in Tetragon where I can alert on all the egress communication. And I also could alert on the metadata service communication. It took me configuration, but it worked. With Kubescape, I automatically got alerts on the egress communication, unexpected egress communication, and unexpected access to the metadata service inside without any further configuration. I want you to know that on one hand, we are doing configurations here. Here, we are not really doing configurations, but we also, I'm just going a little bit ahead, we are getting a little bit more vague answers. So these all things that I'm saying that there is unexpected behavior, it might need a little bit more explanation to go deeper of understanding what's happening here behind the scenes. Now, the third example here is a supply chain attack. In this attack, the attacker is able to inject malware into a container image, which then image is pulled into Kubernetes, into the victim cluster, into a pod, the same image, and then a malware client is launched with the infected image, and it connects to a CNC server outside, in the outside world, is waiting for commands. In this case, again, I could, both with Falco and Tetragon, I could configure them to alert on egresses, which in general. With Kubescape, there was an interesting thing, because if the malware worked during the learning period, then Kubescape said, well, this is normal behavior, so like it's okay. If it was activated after the learning period, then Kubescape alerted on all the new process that it was launched and all the unexpected external communications. So let's go into the last part of where we are configuring, comparing these things through configuration. So both in case of Tetragon and Falco, and this is like coming from right now from me, but I've been talking to a lot of end users as well in the past years. In Falco was very configuration heavy. I've talked to organizations running like 200,000 workloads in their Kubernetes clusters, and it is a mayhem for them, the security team, to configure Falco properly and not to have a lot of alerts. Think about it again, the example I told you about accessing the service account token. The security team doesn't necessarily know which workloads have to access the service account token. There are workloads that has to. This is their normal work. So configuring them is very hard, and then following up changes in these environments are very hard. Same goes more or less to Tetragon. I had to tell here that I had like hard time making Tetragon detecting a few things here. But again, I appreciate Tetragon for how it's built, and I know that it's improving all the time. From a Kubescape perspective, besides the supply chain attack, when there is a question of whether the supply chain attack happens in the learning period or afterwards, it caught these attacks very nicely and got alerts. Now, as I said, the first question is a service account access is an issue or not, or accessing a metadata service, or any kind of behavior, writing into the temp directory. Is it a suspicious behavior or normal behavior of pod? These are very hard things to answer for a security person in a scaled environment. The second thing is the way that things are customized and fine-tuned. So, So Falco, again, has a policy language, a rule language. It's very customizable, again, very used broadly. If someone learns it and able to debug it and so on, it's something it's very, very customizable. Same goes to Tetragon. Again, a caveat here, there are some things that Falco is able to detect very smoothly, like there is an open issue, I think, on Tetragon, which I don't know if it's still an open issue, but for example, detecting reverse shells, which is just checking where is the STD out and the STD in of the process is going to a network socket or not. And Tetragon for a long time had an open issue that it wasn't, like in the policy language of Tetragon, you couldn't define such a detection, very basic detection rule. Kubescape, on the other hand, is not a very easy, compared to Falco, it's not easily customizable. The baselines are CRDs, and the baselines can be really nicely managed. They are very, very, very easy to extend if something was missed in the baselining period. But in general, if you want to write a new detection rule, you have to write it in Go and add it to. And by the way, here we took a deliberate decision not to use a rule engine because it's very hard on the CPU from a performance perspective. So, and this brings us to the second big issue I see. Constant changes in environments are very hard to follow up with these first two rules, and therefore the ability to self-configure, as I see it, is a very important property of any runtime detection. Otherwise, it's very hard in our modern environment to follow up all these changes. So the third thing I wanted to use as comparison is explainability, I call it. So Falco and Tetragon are very clear about what they are alerting on. So you are writing a rule, the alert contains the rule name, then you know that this rule failed. In Kubescape, you have an unexpected process. You have to go into the details of the alert and read all the fields in order to, okay, which process, which pod, what happened. These are very rudimentary information sometimes. Sometimes it's more clear. And the performance comparison from Falco, I think that most of the people who used Falco know that Falco is really hard on CPU. It simply happens because all the events which are happening in the kernel are streamed into all the file opens, new processes, everything are streamed into the user space component, and there is a rule engine that's going over them and evaluating it. And the sheer number that at scale thing that has to be processed by Falco is like very huge, and it can take 20% of a single CPU sometimes. Tetragon, as opposed to that, since they moved all this problem to the kernel, they are bypassing this problem, and they are able to process the rules in the kernel space. Therefore, they are not paying all the overhead of transferring information into the user space, and therefore they are very low on CPU and low on RAM. Kubescape is also low on CPU, pretty much because all these events are not evaluated by a rule engine, but very simple, efficient Go code. Again, this is why we have chosen to do all the evaluation in Go functions and not in a interpreter. But I have to mark here that from a RAM perspective, it uses more memory because the baselines are stored in the memory. It's not a lot, but it's still it's something I wanted to point to. So, in general, takeaways. So Falco is, again, it's a very, I usually tell people that Falco is like an academic project, like it's how someone who has like a blackboard and trying to write up how this thing should work is working, and it's very nice and everything promises very good. But in the practice, it seems to have both from the adoption side in the world, how many big companies are using it, and both from, in general, it seems to have a glass ceiling that it's not able to break, because I think that one of the biggest problems is the configuration, how hard it is at scale, how hard it is to configure, and the other is obviously the performance. In cloud, taking 10-20% of the CPU has a direct cost on the organization's AWS billing. The Tetragon is again, I believe that this project is going to improve a lot in the upcoming years. I think it's very early. So for a security, I don't really see security personnel, except of a few geeks like myself, not really investing too much time, because it's very hard to make it right and detect the things we want to detect. And I again, obviously, because this is a project I belong to, so the anomaly detection, I think it's very, very a big differentiator on the side of Kubescape. So Kubescape, the ability to work not on very specific rules and trying to guess what is going to be the next 0 day, but by default detecting all these anomalies that are actually a cause of an attack, is super interesting. And if in 2 years we'll see that the adoption grows, it will be proving that our point was okay on here. Thank you, and questions?
You mentioned a learning period for Kubescape. Can you tell what that is and what happens during that? And do the other two tools have a learning period?
Yeah. So first of all, in Kubescape, there is a predefined learning period which you can control, during installation for all the pods, which is 24 hours. It simply is just something we learned over the time in our deployments, that you need at least 24 hours because they are simply at scale. There are too many workloads that have daily jobs, and we have to cover it in the baseline. During that time, Kubescape is writing the behavior into CRDs called application profiles, which are really cool, even not just for the sake of the detection, but in general defining how an application works, what kind of files it uses, what kind of network connections it does, what kind of processes we're running, and so on. And it collects them into these CRDs. And during the detection phase, after 24 hours, every event is compared to this baseline. And all the other tools, I've heard that for, I don't know, might not be right, but I think the owners of the project Falco Sysdig does have a learning feature, but I don't really know how it works, so I don't want to really go into that.
So you mentioned like a high performance utilization, with respect to Falco. Was there like, did you try that like with a specific driver, like with the kernel module driver or the modern eBPF driver?
Only modern eBPF.
Okay, and with the default rules engine, or did you get rid of the default rule engine and then write your specific rules engine?
No, I two things. Like during this testing, I used the default rule engine. I added rules and removed rules. I cannot, like all the other people I've talking to, like who are like try to use Falco and like again at big scale, I don't know what they use, what kind of rule engine they tried out, so I cannot comment on that.
Thank you. Last question, probably.
You mentioned that alerting was sort of the test as to whether or not it was working. Any of these tools, are they actually stopping the behavior when it sees that a malicious action is occurring?
Stopping behavior. So prevention.
Preventing? Yeah.
Prevention. So in eBPF, prevention is not a very simple thing. I don't know if Tetragon does it today, but if I have to guess that there will be, the first tool that will do prevention is going to be Tetragon, because just their sheer knowledge of eBPF is there, that they know how to do that. And if anyone is interested, by the way, tomorrow I have a talk with a friend from Microsoft at eBPF Day, where we are going to talk of how to do prevention through eBPF. It's not a simple thing, but it's super interesting. There are problems there as well. But in general, by default, none of these are doing prevention.
I'll take one more.
And I have a last comment as well. So,
did you publish like the Falco rules that you did end up using to detect those attacks and the resource utilization benchmarks?
No, but I will. It's a right comment. I will publish it. I will publish it afterwards. I will go back to the hotel today or tomorrow, and I will publish it.
Awesome. Thank you.
Yep.
So just one thing. If anyone's interested in swag for Kubescape, should come to the Kubescape Project Pavilion on which day? Thursday afternoon, and meet the Kubescape team. Okay, thank you very much.